Welcome to Burlap Teachers. Enjoy the video.
You start by validating drivers and runtimes so the GPU can accept work. Once done, switch the machine to a performance power profile and reduce CPU throttling so the GPU isn't starved. Next, profile briefly to find compute hotspots. These are the functions you will move. Make sure to prioritize parallelizable kernels like matrix math, convolutions, or texture shading. You're not rewriting everything. You're replacing the bottlenecks with GPU-friendly implementations and preparing data paths for high-throughput transfer. Now you implement the actual offload. Translate the hot loops into GPU kernels or call optimized vendor libraries to avoid reinventing the wheel. Once implemented, batch inputs to increase GPU occupancy and throughput. Larger batches and vectorized operations yield better utilization. Use asynchronous device copies and multiple streams to overlap compute and transfer. Make sure buffers are pinned and contiguous to reduce latency. Finally, remove unnecessary host device synchronizations. Let the GPU queue work so its pipelines stay full and efficient. Finish by tuning. Adjust kernel block sizes, memory coalescing, and shared memory usage to maximize bandwidth and reduce divergence. Once done, measure occupancy, throughput, and thermal limits. Increase batch size or concurrency if the GPU is underfed. Also pipeline preprocessing on the CPU so the GPU never waits. If you see low GPU usage, inspect PCIe or NVLink throughput, driver warnings, and hidden synchronization calls. These usually cause stalls. Make one targeted change at a time, reprofile, and iterate until stable.
Thanks for watching. Consider subscribing if this video helped you.